Urrego. Today we're going to factor this expression, okay? The first thing we do always is to see how many terms do we have in the expression. In our case, we have 1, 2, 3, 4 terms. How do we know the number of terms? They're separated by a minus or by a plus, all right? That's how we know how many terms we have. So we have 1, 2, 3, and 4 terms. Now, because we have 4 terms, the only way we can factor this is by grouping. Not the only way, but the most common one is by grouping. So grouping, every time we have 4 terms. How do we factor? We group. That's the name. We group. We make groups of 2. The first 2 terms and the last 2 terms. Make sure that this third sign is attached to that. First 2, last 2. On each parenthesis, what I'm going to do is I'm going to do GCF, the greatest common factor. Okay? So what's going to happen is I'm going to see what's in common between them. 3 is common, so I take 3 out. The x is also common, so therefore I take the x with the lowest exponent, which is going to be the x squared. What goes inside? Inside, my first term is the first term divided by my common factor. First term divided by my common factor. So 3 divided by 3 cancels out. X cubed divided by x squared is going to give me x. So first, you subtract the exponents. Minus 3x squared divided by 3x squared. 3 divided by 3 is 1. Well, cancel out. X squared divided by x squared cancels out. So everything cancels out. This is what I'm saying. 3x squared divided by 3x squared. Because the same thing on top and bottom, the answer is 1. They cancel out. All right? So this is 1. And I'm done with my first parenthesis. Same process I do with the second parenthesis. But if you notice, is there anything in common between those two? Not like this is specific. There's not like a 3 or an x popping out of that we can see, we can notice right away what's in common. So there's nothing huge as a common factor. What I do is that I need to take a 1 as a common factor. In my case, I'm going to take a positive 1 as a common factor. Why? Because the positive is not going to change anything on the parentheses. And the 1 will not change anything as well. So basically, I just need to rewrite the same parentheses. Now, what was the reason for me doing that? Because I know that my 2 parentheses, when I'm doing grouping, they have to be the same. These 2 parentheses have to be the same. So if I had this parenthesis already, and then I notice that my second parenthesis is the same thing as the first one, then I just take a positive 1 out as a common factor and I rewrite the second parenthesis. So far it's right because the 2 parentheses are the same. Now, technically what we have here now is that I have 1 term from here to here plus another term from here to here. So I have to do GCF as well. Okay? So I'm doing GCF between these 2 terms. What's in common between those 2 terms? We see that we have the same parentheses on both. So that's going to be my common factor, GCF. All right, the first parenthesis. Now I open, like I did over here, I open a parenthesis and I do the first term divided by that. Parentheses will cancel out and I'll have a 3x squared. Second term divided by x minus 1. The parentheses are going to cancel out and I will have left plus 1. Every time you factor, I'm done factoring at this point. Every time you're factoring, you always check inside those parentheses to see if there's anything else you can factor. Here, I can easily have a difference of squares. Why? Because I have a minus and I have a 1, which is perfect square. But then the x is not a perfect square. So therefore, that's not a difference of squares and I'm done. Second parenthesis, I see if I have maybe a sum of cubes, but then the x is not a cube and the 3 is not a cube. There's no GCF. So basically that will be my answer as well. So this is my answer. Okay, and I just did factor by grouping. Again, 4 terms. Thank you very much.